Welcome students once again into the class of number theory, and today we are going to start the new chapter, that is arithmetic functions. Arithmetic functions. This is the new chapter we are going to start today, and let us first define what an arithmetic function is. An arithmetic function is a function whose domain is the set of natural numbers. So any function whose domain is the set of natural numbers will be now onwards known as an arithmetic function. So let us have some common examples then, and after giving some common examples we will move on to the brief concept and theorems related to those arithmetic functions. One of the functions is dn, that is known as the divisor function, and dn means number of divisors of n, where n is definitely a natural number because we are calling this dn as an arithmetic function. So n must be a natural number. The second common function is sigma n. It is sum of divisors of n. Earlier it was the number of divisors of n, and now it is the sum of divisors of n. This is sigma n. The third one is sigma kn. It is sum of kth powers of divisors of n. Another function is phi n, Euler's function, Euler's totient function, which we have already discussed in the previous video. So what is phi n? It is the number of natural numbers less than n which are co-prime to n. As in a previous video we have discussed that, for example, if you are dealing with phi 10, so what are the natural numbers less than 10 that are co-prime to 10? These are 1, 3, 5 and 7. So phi n is the number of those. So how many are there? 1, 3, 5 and 7. That means 4. So phi 10 is 4. Another function is mu n, which is defined by Mobius. So it is called Mobius function, and Mobius function mu n is, it assumes the value 1 if n is equal to 1. It is 0 if n is not square free. Not square free means square of some prime number divides n. For example, 12. 12 is not square free because square of 2 divides 12. Similarly, 54 is not square free because 54, yes, 9 divides 54, it's okay. So 54 is not square free, and so on. There are so many numbers. So for those numbers, for those natural numbers, the value of mu n is 0. And the third case, the last case, if that n is square free, and if n is square free, then in the canonical form of n, the prime numbers will occur with power 1 only. That means n can be written as p1, p2, p3 and so on, pr, where these pi's are distinct primes. Because if any two of these are same, Suppose P1 and P2 are same, then P1 square will divide n and it will not be square free, and this will be the second case and the value will become 0. So this is the case of square free natural numbers, and in this case how many prime numbers are there in the product? These are r. So the value of mu n is r, sorry, minus 1 raised to the power r. This is the value of mu n in the third case. So these are some common arithmetic functions, and let us discuss values of these functions. For some values, let us have some values. I'll try to write the natural numbers on the board, and let us see up to how I can write. So n, I am writing n 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think it is more than enough. For these values of n, let us see what is the value of dn. First of all, what is the value of dn? Number of divisors. So how many divisors this one have? It is only 1. So dn is 1. If you take n to be 2, then d2. How many divisors of 2 are there? These are 1 and 2. So there are 2 divisors. So dn is 2. That means d2 is 2. If you take n to be 3, what is d3? d3 means the number of divisors of 3. And once again, there are only 2 divisors, 1 and 3. So the value is again 2. If you take 4, how many divisors of 4 are there? These are 3. Which 3 are these? 1, 2 and 4. So d4 is 3. 5. 5, you are having only 2 divisors, 1 and 5. So d5 is 2. 6. How many divisors are there? 1, 2, 3 and 6. So 4 divisors are there. So d6 is 4. d7. How many divisors of 7 are there? Only 2. 1 and 7. So d7 is 2. d8. How many divisors of 8 are there? The divisors of 8 are 1, 2, 4 and 8. So how many divisors are there? These are 4. 9. How many divisors are there? 3. These are 1, 3 and 9. So d9 is 3. What is 10? What is d10? Number of divisors of 10. And number of divisors of 10 are 1, 2, 5 and 10 itself. So 4 divisors are there. So d10 is 4. Now let us move on to the next function, that is sigma n. So what is sigma 1? There is only one divisor, that is 1, and sum of all divisors is again 1. For 2, there are 2 divisors, 1 and 2. So their sum is 3. So sigma 2 is 3. For 3, the 2 divisors are 1 and 3. So what is their sum? Their sum is 4. So that means sigma 3 is 4. Now 4. What are the 3 divisors of 4? These are 1, 2 and 4. And what is their sum? That is 7. So d4 is 7. 5. How many divisors are there? 2. Which are these? 1 and 5. What is their sum? 6. So sigma 5 is 6. Now 6. What are the 4 divisors of 6? 1, 2, 3 and 6. And what is their sum? Their sum is 1 plus 2 plus 3 plus 6, that is 12. So it is 12. Now 7. The 2 divisors are 1 and 7. So their sum is simply 8. 8. What are the 4 divisors? 1, 2, 4 and 8 itself. And their sum is 15. So sigma 8 is 15. What is sigma 9? The 3 divisors are 1, 3 and 9. And their sum is 13. So sigma 9 is 13. And similarly, the divisors of 10 are 1, 2, 5 and 10. And their sum is 18. So sigma 10 is 18. Let us discuss sigma 2n. Sigma 2n means here the sum of squares of divisors of n. So here there is only one divisor and that is 1. Its square is 1. So the sum is 1. Here the 2 divisors are 1 and 2. And sigma 2n will become 1 square plus 2 square, that means 5. For 3, the two divisors are 1 and 3. So their squares and then sum 1 square plus 3 square is 10. So sigma 2, 3 is 10. 4. The three divisors are 1, 2 and 4. So their sum of their squares 1 square plus 2 square plus 4 square. So it is 21. So sigma 2, 4 is 21. 5. Only two divisors are there, 1 and 5. So the sum of their squares is simply 26. 6. The four divisors are 1, 2, 3 and 6. The sum of their squares is 1 plus 4, 5, 5 plus 9, 14, 14 plus 36, 50. So it is 50. For 7, the only two divisors are 1 and 7 and the squares, sum of their squares is 50. So this is 50 again. For 8, the four divisors are 1, 2, 4 and 8 and the sum of their squares is 1 plus 4, 5, 5 plus 16, 21, 21 plus 64, 85. So it is 85. For 9, the three divisors are 1, 3 and 9 and the sum of their squares is 91. So it is 91. For 10, the four divisors are 1, 2, 5 and 10 and the sum of their squares is I think 130. So 130 is the value of the last one. These are dn, sigma n and sigma 2n. Now let us move on to phi n, and this I have already discussed. For 1 it is phi 1 is 1. For 2, how many numbers less than 2 are co-prime to 2? This is 1. For 3 it is 2. For 4 it is 2, 1 and 3. For 5 it is 4, 1, 2, 3, 4 all. For 6 these are only 2, 1 and 5, so there are 2. For 7, all the 6 numbers less than 7 are co-prime to 7. For 8, these are 1, 3, 5 and 7, so 4. For 9, these are 1, 4, 5, 7 and 8 also, so it is 6. So it is 6. 1, 2, 4, 5, 7, 8. For 10, these are 1, 3, 7 and 9. So it is 4. And now, let us discuss the values of their Mobius function, mu n. For 1, mu 1 is already defined in the definition, it is 1. 2, it is a square free and it contains only one prime number 2. So it is minus 1 raised to the power 1 is minus 1. The same is the case for 3. So it is also minus 1. 4, it is not square free because 2 square divides 4. So the value is 0. 5 is a prime number and in its canonical product is the only one. So minus 1 raised to the power 1 is again minus 1. For 6, in the canonical product you are having two prime numbers 2 and 3. So 2 prime numbers, minus 1 raised to the power 2. So it is 1. Then 7, again prime. So it is minus 1. 8, it is not square free because 2 square divides 8. So the value is 0. 9 is again 0 because it is also not square free. 10, having two product of 2 primes, 2 and 5. So minus 1 raised to the power 2, that means 1. So I think from this table you can well understand these arithmetic functions dn, sigma n, sigma kn, phi n and the Mobius function mu n. Now let us see the general case. For any n, what is the value of dn? Let us see what is dn in general. We know from the fundamental theorem of arithmetic that every natural number n can be uniquely expressed as a product of powers of primes. That is known as the canonical form or canonical product of n. So this n can also be written as p1 power alpha 1, p2 power alpha 2, p3 power alpha 3 and so on pk power alpha k. Now look at one particular product I am going to write. This is 1 plus p1 plus p1 square plus and so on p1 power alpha 1, first bracket. Second bracket, 1 plus p2 plus p2 square plus and so on plus p2 power alpha 2 and so on, 1 plus pk plus pk square plus and so on pk power alpha k. Look into this product. This is some special product. Why? If you expand this product, what you are going to get? When you multiply this 1 by 1 by 1 and all 1, you will get 1. And 1 is the divisor of this number because 1 is the divisor of every number. If you take p1 from here and 1, 1, 1 from all the rest of the brackets, you will get p1. And p1 is also a divisor of this number. Similarly, p1 square and all 1 is a divisor. P1 cube and all 1s is another divisor. In fact, you take any one from here, any one from here, any one from here. Suppose p1, p2 cube, p3 square, p4 power 5, pk power alpha k. So it is another divisor of this number. So that means this product contains all the possible divisors of this number n. And how many terms this product will have will be the number of divisors of n. And how many terms are there? I am giving just you an example. Suppose you are having a plus b plus c plus d into e plus f plus g. This is a product. Here you are having 4 terms, here you are having 3 terms. When you will get product, how many terms will be there? Definitely these will be 4 into 3, 12. You will get 12 terms. A, E, A, F, A, G, 3 terms. B, E, B, F, B, G, 3 terms. C, A, E, C, F, C, G, 3 terms. D, E, D, F, D, G, 3 terms. So total 12 terms. 4 multiplied by 3. Similarly, here in this product, the first bracket contains how many terms? It contains alpha 1 plus 1 terms. Alpha 1 from here to here, p1 power 1, p1 power 2 and so on, p1 power alpha 1 and one additional term, 1. So it contains alpha 1 plus 1 terms. The second bracket contains alpha 2 plus 1 terms and so on. The last bracket contains alpha k plus 1 terms. So how many terms will be there in the product? The number of terms will be alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1 and so on, alpha k plus 1. This will be the number of terms in this product. And I told you earlier that all the terms of this product are precisely the divisors of n. So these much divisors of n will be there, and the number of divisors we denote it by dn. So it is equal to dn. So number of divisors of n is given by this relation, and it can also be written as product alpha plus 1, where some p raised to the power alpha, some prime power alpha, max divides n. Max divides n means p alpha divides n, but p alpha 1 plus 1 does not divide n. This is p alpha max divides n. So here p1 alpha 1 max divides n, because p1 alpha 1 is a factor, but p1 alpha 1 plus 1 is not a factor. So p1 power alpha 1 plus 1 is not a divisor of n. p1 alpha 1 max divides n. So these are the terms alpha 1 plus 1, alpha 2 plus 1, alpha 3 plus 1, alpha k plus 1. This product can be written as, in short, product. This pi is used for product. So it is product of alpha plus 1, where p alpha, for some prime number p alpha max divides n. So this is the general value of dn. For example, suppose you are to calculate d48. You have to calculate d48, or let it be a bigger number. Let it be 180. So it is not so easy to find all the divisors of 180 on finger. It will take too much time. So this formula we will use. How to use this 180? Try to write it in canonical form. So how many powers of 2 will be there? 1 power of 2 will reduce it to 90, the second power will reduce it to 45. So it is 2 square. And now we are left with 45. So 45, the next prime is 3. 1 3 will reduce it to 15, the second 3 will reduce it to 5. So it is 3 square and 5 power 1. You can say this is the canonical form of 180. So this is your alpha 1, this is your alpha 2, this is your alpha 3. So what should be the value of 180? Alpha 1 plus 1. So 2 plus 1 multiplied by alpha 2 plus 1. Alpha 2 is again 2. So 2 plus 1 into alpha 3 plus 1. And alpha 3 is 1. So it is 1 plus 1. That means 3 into 3 into 2. So 18. 18 divisors of 180 will be there. So how many divisors of 180 are there? The simple answer is 18. So it is how to find Dn. From the same concept, we can evaluate sigma n. So let us see how sigma n can be obtained from the same concept. So now our next aim is to find the value of sigma n. Once again, n can be written as product of powers of primes by using fundamental theorem of arithmetic. And once again consider this product. As we have discussed earlier, when you will open these brackets, you will get all the possible divisors and they will be separated by plus sign, because there are everywhere you are having plus sign. So all those divisors will be separated by plus. That means the expansion will give you the sum of all divisors of n. The expansion of this product will give you the sum of all divisors of n. That means the sum of all divisors of n is nothing but equal to this product. And in this product, this first bracket, you can easily obtain the sum. What it is? It is P1 power alpha 1 plus 1 minus 1 upon P1 minus 1 by using the sum of geometric progression GP. Similarly, the second one will be multiplied by P2 alpha 2 plus 1 minus 1 upon P2 minus 1 and so on. In the last you will get Pk power alpha k plus 1 minus 1 upon Pk minus 1. And once again, this product can be expressed as, in short, product, this pi is used for product. So product of what? Product of P raised to the power alpha plus 1 minus 1 upon P minus 1, where P raised to the power alpha max divides n. So it is the direct formula for sum of divisors of n. So this is the case of 180. So let us see what is sigma 180. Because we have already expanded it, so why I am not taking a new number. So it is your P1 power alpha 1, P2 power alpha 2, P3 power alpha 3. In this product, the first term will become P1 power alpha 1 plus 1. So 2 power 2 plus 1. 2 power 2 plus 1 minus 1 upon 2 minus 1 is the first term. What is the second term? You are having here 3 square. So you will get 3 power 2 plus 1 minus 1 upon 3 minus 1. And in the last term, you will get 5 raised to the power 1 plus 1 minus 1 upon 5 minus 1. So let us solve it. What it is? It is 8 minus 1, 7 divided by 1. So it is 7 multiplied by 3 power 3, 27 minus 1, 26 divided by 2, 13 into 25 minus 1, 24 divided by 4, 6. So it is 7 into 6, 42 multiplied by 13. So you will get 546. So this 546 is the sum of all divisors of 180. So this is direct formula for sigma n and the direct formula for dn. Another question I will discuss about this concept, that if dn is given, how to obtain the number? Because dn can be same for many natural numbers. So the question may be find the smallest n. So let us have one question of that type. So I am taking this particular question, find smallest n such that dn is equal to 10. dn is equal to 10. So what we are given with? We are given that dn is equal to 10. Right now we have proved that what is dn? dn is the product of the terms of the type alpha 1 plus 1 where p power alpha max divides n. So if I consider n to be p1 power alpha 1, p2 power alpha 2 and so on, pk power alpha k, then this dn will become alpha 1 plus 1 into alpha 2 plus 1 into and so on alpha k plus 1 is equal to 10. Now this 10, this is either 2 into 5 or 10 into 1. There is no third way to write it as a product of different natural numbers. It is the only way. These are the only ways. So we will consider one by one. So 10 into 1 we can write 10 only. No need to write 1 because if you consider any one of these equal to 1, alpha 1 plus 1 is equal to 1. So 1 will be cancelled and alpha 1 will become 0, which is useless. So I am writing it as 10 only. If you consider this product as the first case, that means you are having only two brackets. So alpha 1 plus 1, alpha 2 plus 1 is equal to 2 into 5, or in the second case 10. So only one bracket will be there. Alpha 1 plus 1 is equal to 10. In the first case, you will get alpha 1 plus 1 is equal to 2. That means your alpha 1 is 1 and your alpha 2 plus 1 is equal to 5. That means your alpha 2 is equal to 4. Or in this case, you will get alpha 1 is equal to 9. So what type of number you will have? This is your number. So go back to this number. In this case, what will be your n? If you take the first p1 as p, the second p2 as q. So it is p raised to the power 1, p raised to the power 1 and q raised to the power 4. And no more terms will be there because there are only two alpha 1 and alpha 2. Or in the other case, your n will be, there is only one 9. So it is p raised to the power 9. P raised to the power 9. So p power 1 can be written as p only. So your n is of the type pq power 4 or p power 9. So let us now take the minimum possible values of p and q. And let us see what will happen. In the second case, the smallest p possible is 2. So if you put p to be equal to 2 here, 2 raised to the power 9 and 2 raised to the power 9 is 512. So your n is 512 minimum in this case. The smallest, the least possible in this case. Let us discuss these cases now. If your p is 2 and q is 3, then 3 raised to the power 4 is 81 multiplied by 2. The smallest possible number will be 162. Another reverse case. Take p to be 3 and q to be 2. What will happen? 2 raised to the power 4 is 16. 16 into 3 is 48. So the smallest possible value is 48. And out of these three, which one is the smallest? The smallest one is 48. So 48 is the smallest number such that the number of divisors is 10. So this was an interesting question related to the number of divisors of n using the concept of arithmetic functions. And with this question, I am going to stop this video here. In the coming videos, in the next videos, we will discuss more and more questions about arithmetic functions. Till then, thank you. Thank you once again.